Hello, today we're going to clearly understand the difference between velocity and acceleration. So, velocity and acceleration. These two ideas are connected, but they are not the same. And in grade 11 physics, mixing them up causes a lot of mistakes. Let's start with velocity. Hold on. Velocity is defined as, sorry, it, it can is it's defined by delta x over delta t, otherwise known as displacement over time. But more importantly, velocity is a vector quantity. Vector quantity. This means it has both magnitude, well, basically both size and direction. And speed is different. Hold up. So speed, for one, speed is a scalar quantity. Scalar quantity. Which means it only tells us how fast something's moving. Something is moving, such as like if a car is moving at 15 meters per second, that's speed. This is speed. However, if it's moving 15 meters per second east, this this is velocity. Sorry, that says velocity over here. The speed over here. So once again, speed is a scalar quantity, determines how fast something is moving. 15 meters per second is speed, while 15 meters per second east would be considered velocity. Now let's get to the direction is basically what makes it velocity. Alright, let me write it down here. Direction, what? And this is important too. You have to keep this in mind. But here's an even more important thing. So I'm gonna start. If di- direction changes, velocity changes. Even if the speed stays the same. So just to recap, this is a major thing about velocity. Direction changes, velocity changes, even if the speed stays the same for, yeah, even if the speed stays the same, if the direction changes, so does the velocity. Now I'll give you an example. So basically, imagine a car moving in a circle at constant speed. So here's a car, and it's moving in a circle. So let me just go here. Moving in a circle. So its speed doesn't change. Hold up, let me make this. Speed doesn't change, but its direction is constantly changing. Constantly changing. So just to recap, well, here's an example of like the car driving in a circle. Its speed doesn't change as it's, it's at a constant speed, which means that it has that same speed throughout, but its direction is constantly changing, therefore its velocity. Now, let's, yeah, sorry. So the thing was bugging out. So, like I said earlier, acceleration is defined as rate of change for velocity, rate of change for velocity of all or of. So, so mathematically, acceleration, which can also be defined as just a, equals change of time, which is just delta t, divided by change of velocity, which is just delta v. This can also be equal to this can also be equal to let me just Tf minus Ti over Vs minus Vi. Just in case you don't know, this is final time minus the initial time, which gets you delta t, aka change in time, and Vs, which is the final velocity, subtracted by the initial velocity, can get you delta v. So these two equations can both help you get acceleration. Now, because velocity is a vector, so is acceleration. Alright? Because velocity So is so is acceleration. And that's an important thing to note. Now this is the most important idea of this lesson. This is a very, very, very important thing to note. Acceleration does not just mean speeding up. This is a very important thing to note. So make sure to note this. And acceleration happens when velocity changes. Because basically what acceleration is the rate of change of velocity. This is what it basically is. And velocity can change in two main ways. One, firstly, magnitude, aka size, can change. Right? Basically, what this means is objects can either speed up or slow down. That's the first thing to know. The second thing is, hold on, direction can change. This basically means the object turns. Now, one important thing to note is if either one of these things happen, the object is accelerating. So if either of the two happen, acceleration is occurring on the object. So if either one of those two things I previously mentioned happen, then that means acceleration is occurring on the object. This is basically what this says here. So, for example, if a car speeds up, hold on. So if a car speeds up, for example, is it still accelerating? No, if a car speeds up, it is accelerating. This is an example of acceleration. If a car if car slows, this might be shocking, but it's actually still accelerating. Still accelerating. But an important thing to know about this scenario about the car slowing down is the acceleration is in the opposite direction of motion of motion. So a summary of what I wrote here is if a car, for example, if a car speeds up, it's accelerating. If it slows down, it's still accelerating, but the acceleration is in the opposite direction of motion. This is what I basically wrote here. Sorry, so suppose a car starts from rest and reaches a velocity of 20 meters per second M plus S is just another way of saying meters per second in 4 seconds. So some things we can piece out are initial velocity is 0 meters per second because the car starts from rest. This is its initial velocity. Next, its final velocity is 20 meters per second because it reaches a velocity of 20 meters per second, and it's the only information that we have, the only other information we have of velocity. And the time that we have, 4 seconds. And what our goal is we need to find acceleration. So how do we suppose we can find acceleration? Well, if we remember from the last time I covered this, we know that acceleration has a formula. A equals to delta V over delta T. And remember we said that delta V over delta T can also equal Vf, meaning final velocity, subtracted by initial velocity, divided by final time minus initial time. Well, we don't have a final time or initial time, since obviously our T is equal to 4. So we can actually plug this in for delta T, because it's our only other variable that's related to time. But we actually have our Vf and Vi. If we remember, our Vf was 20 meters per second, and our Vi is 0 meters per second. So if we plug these values in, we can actually just leave this as delta t instead of tf minus ti because we only have one value for time. Now let's just write that. Delta t. Now let's write our formula. 20 meters per second subtracted by 0 meters per second all over 4 seconds. So now we calculate. 20 minus 0 is obviously 20. At least for 20 meters per second. All over 4 seconds. So if we know our math, we know that 20 divided by 4 is equal to 5 meters per second squared, because we actually have 2 seconds. But what exactly does 5 meters squared mean? Well, let me show you. This 5 meters per second over that we have here, this means the velocity of our object increases by 5 meters every second. 5 meters per second every second. 5 meters second every second. Now let me show you this. So after 1 second, for so after 1 second, velocity is at 5 meters per second. After 2 seconds, velocity equals 10 meters per second. After 3 seconds, so t is equal to 3 seconds, v must equal, yes, 15 meters per second. And then for if t equals 4 seconds, v equals 20 meters per second, so on and so forth. Now, let's summarize this video. Do a brief summary. All right. Velocity tells us how fast something is moving and in what direction. And acceleration, on the other hand, acceleration tells us how velocity tells us how velocity changes over time. So, velocity tells us how fast something is moving and in what direction, while acceleration, this is acceleration, tells us how velocity changes over time. It tells us how velocity changes over time. Sorry, hold up. So velocity tells us how fast something is moving and in what direction, while acceleration tells us how fast velocity changes over time. Next, next, if velocity changes in both magnitude and in size, which is the same as magnitude, direction, or both, or both, object is accelerating. So just to recap the summary, of velocity tells us how fast something is moving and in what direction. Acceleration tells us how velocity changes over time. If velocity changes in magnitude, direction, or both, the object is accelerating. And understanding the difference is essential before moving on to kinematics equation and motion problems in grade 11. I hope you like this video. It's my first ever video. Please comment and suggest feedback. I'll be more than happy to listen to it. And have a good day. Have a good day. And please subscribe.